So I will be introducing about our project first. So our project that we plan on doing is speech recognition to control the level of brightness of the lighting of a home. So in order to achieve this, we use peripherals such as the IMP441 microphone to get the signals to be used by the microcontroller. And in this case, we use the STM32F446RE board. So the output will be in ADC, and the output will be viewed by a serial port monitor called Teratem, and this is one of the examples of the output that we got from the microcontroller. So the next step after we have successfully be able to get the signals from the mic and view it on Teratem, the next step is to implement the keyword spotting algorithm in order for the microcontroller to be able to recognize what word is received from the signal gotten from the mic use. So the algorithm that we are going to use, we refer it from a journal that we will attach together in the report for reference. And the idea on how we plan on using this algorithm will later be explained by my team members.
Hello, Assalamualaikum, Zafri here. So for the hardware connection, we have four main components, which is the microphone, the audio codec, speaker, and UART for serial monitor. And this is our circuit connection. The input will be the microphone signal and it will be processed by the MCU. The signal would then be used for two functions. The first is we would direct the I2S signal to an audio codec for debugging. And secondly, the mic signal will be processed by the neural network to know what keyword it is receiving. From that keyword, the MCU would control the analog signal value that it will be giving out. In real scenario, it would be a smart light bulb, but in this project, we will just show the value on the serial monitor. And physically, this is our microphone, this is the nuclear board, and this is our audio codec, and this is the speaker. Now I will talk on how we applied CMSIS in our project. We use CMSIS DSP and CMSIS NN for two main reasons. The first is we implemented a low-pass IIR filter for microphone's noise reduction by using CMSIS DSP. And secondly, we used CMSIS NN to create a depth-wise separable convolutional neural network for keyword spotting to control the brightness level of the light in houses. So no point in delaying, I'll just mention it right now. The keyword spotting algorithm failed to be integrated in our project, and I will be explaining where we played later. For now, let's move on to CubeMX peripheral configuration and coding. I'll start with I2S first. For the microphone, we use I2S2 and in our project, and this is the parameter settings, and this is the DMA settings. Whereas for the audio codec, we use I2S3, and this is the parameter setting, and here is the DMA setting. As for the serial monitor, we use USART2, and this is the parameter setting. Now to verify the microphone signal. As it is an I2S signal, it cannot be viewed as a waveform like PDM or PCM or analog signal. The best way to verify I2S signal is through oscilloscope or converting it into a sound file or redirecting the microphone signal into an I2S speaker. These are our method to verify the microphone signal, which I will be demoing it. Here's a quick demo. This is our microphone signal printed on Teratem serial monitor. We would then log this value into a CSV file which looks like this. And then we convert the hexa value into a binary value. And from here we could see that the final few bit has a 0 value. And in our timing datasheet, we could see that after 24 bit of the microphone signal is sent, it would then get tri-stated, which is value 0. So our communication is successful. Here's another demo. So after our group managed to get our hand on an audio codec, which is this PMOD I2S2, we could redirect the microphone signal into the MCU and into the audio codec and pass it to the speaker. Here's a quick demo that shows our microphone signal is valid. Test. 1, 2, 3. So I'll just blow the into the microphone over here so that you know the voice is coming from here.
Okay, hello, assalamualaikum. Okay, I'm going to talk about infinite impulse response, which is IRR low pass filter. Actually, IRR filter are one of the two primary type of digital filter used in digital signal processing (DSP). Okay, infinite impulse response is a property applying to many linear time invariant system that are distinguished by having an impulse response which does not become exactly zero past a certain point but continue indefinitely. In our case, we use IRR low pass filter and it was used on our microphone. And we do the IIR low pass filters so that we can use CMCs.
So after obtaining IIR low pass filters coefficient, we coded it in Kyle. Here's a code snippet whereby we declare CMC's DSP necessary variable for IIR filter, declare filter coefficient, initialize the IIR filter structure, and pass through the microphone signal into the IIR low pass filter. So after passing through IIR filter, the microphone signal's volume got lower and the noise is reduced. Here's this quick demo. Test 1, 2, 3. This is the original mic signal. Notice that there is a ringing high frequency sound behind my voice. Test 1, 2, 3. This is the IIR filtered mic signal, and notice that the volume got lowered down, but the ringing high frequency, which is the noise in my mic signal, is gone. So remember from the hardware connection, we said we would be having two output. So the speaker part is done. Let's move on to the next one. Recall that the main purpose of this project is to perform keyword spotting for changing light brightness level, but it failed. The output was supposed to be an analog signal printed on teratom serial monitor to indicate the light brightness level. Unfortunately, we failed at integrating keyword spotting algorithm from the paper shown earlier. Here's a demo on the effort that was done for it. We used the Cube IDE due to Kyle's 200 kilobyte flash upload size limitation, and we've included all the CMCs, DSP, and CMCs and necessary files and libraries. However, after compiling the project, the IDE failed to recognize C++ syntax as the keyword spotting algorithm from the paper used C++ syntax. We've changed the project to C++, but somehow there is still error. This is an example of the IDE using C compiler on C++ syntax error. Notice C plus is C++ OOP syntax. So that's all we managed to do in this semester. If given more time, we might have a shot in completing the whole keyword spotting. But I think we've managed to show that we are able to use CMCs from the IIR filter demo. That's all from Cook 4. Please like this video for our carry mark, and thank you for watching.